Okay, here we go, ladies and gentlemen. Find the values of x in the interval from 0 to 2 pi. Notice that's in radians, eh? Not in degrees. Does each of the following functions have a horizontal tangent? Remember, that means... Right, that means dy over dx is 0. All right. So the function here is x radical 3 plus 2 cosine of x. Now, what you may want to do here is say f of x is equal to, because radical 3 is your, is your coefficient there. You might want to write that as radical 3 times x plus 2 cosine x. Right? Might help you in taking the derivative. All right, so f prime of x here, right? Because the derivative of 2x is 2, right? The derivative of 4x is 4. The derivative of radical 3x, or x radical 3, right, is radical 3. Plus 2 cosine of x. Right, so take the derivative of cosine of x and just times it by 2. That's what I do, Plus 2 times negative sine of x, right? Isn't that the derivative of cosine? So let me clean this up here a little bit. F prime of x is going to equal, this is going to be negative 2 sine x. I'm going to write that first, plus radical 3. Now remember, f prime of x, people, right? Another way to write f prime of x is dy dx, right? The derivative of y with respect to x. So remember, what we're looking to do here, we're looking to find, right? We're looking to find the value or values of x, right? That will produce a tangent line, horizontal tangent line, meaning slope of 0. We're finding x. We know the slope is 0. So what do? Right? Finding x here to get, right, a slope of 0. Right? dy dx is 0. So you're going to set, right, negative 2 sine x plus radical 3, you're going to set that equal to 0. And then solve for x. Right, goes back to what I was saying before up here. Right, we're not given the x. I'm giving you the slope. I'm telling you the slope is 0. At what x with negative 2 sine x plus radical 3 is going to produce you a slope of 0. So, yeah, I don't know how much you remember about trig equations, right? That's what we have here. A linear trigonometric equation. All right. What you want to do here is you want to isolate for the trig function. Just sine of x. You want to isolate for that. So I'm going to move the radical 3 over to the other side by subtracting. So negative radical 3 is going to equal negative 2 sine of x. Divide both sides here by negative 2. And I'm going to get sine of x here to equal a negative radical 3 divided by a negative 2 is going to be radical 3 over 2. Right? So the sine of, what x here, remember, in radians, is going to produce a radical 3 over 2. Now, isn't that an exact value? Right? Radical 3 over 2. Remember? The old chart. The sine of pi over 3, isn't it? The sine of pi over 3 is radical 3 over 2. Okay, that's our reference angle, by the way. Right, so let me write this down here just as a little side note for us. Let me get rid of this. I don't need that anymore, right? So the sine of pi over 3 is radical 3 over 2. All right. So what else do we need to remember here, right? Is sine is positive in quadrant 1, but it's also positive in quadrant 2, So we need to get the quadrant 2 angle also here. So quadrant 1 we got, right? It's pi over 3 is the angle. Now we got to get the quadrant 2 angle. So do you guys remember what we did here to bring it, to get the reference angle? In a quadrant outside of number 1, quadrant 1. What we did there, y'all? Anyone remember? Well, I think we worked in degrees when we talked about this. Right, if you remember, right? We said, quadrant 1 is your angle. Quadrant 2 is 180 minus the angle. Quadrant 3 was 180 plus the angle. Quadrant 4 is 360 minus the angle. Do you guys remember that? So that's what you did to get the angles in those respective quadrants. And the angle is your acute angle, your reference angle. But keep that in mind. So basically, what am I looking for here? I want an angle in quadrant 2 whose reference angle, okay, is pi over 3 radians. Now, pi over 3 radians is 60 degrees. So if I use numbers here, it might be more helpful for you. All right, so I want an angle in quadrant 2 whose reference angle, you know, a positive acute angle formed by the x-axis and its terminal side here, its terminal ray is 60 degrees. All right, so that's my reference angle. But I want an angle in quadrant 2. So this, you know, this angle here, right? I want this angle that has a reference angle of 60 degrees. Now, what are you doing to get the measure of this angle here, right? You would do 180 minus 60. All right, you gotta get a linear pair there. But remember, we're in radians. 180 degrees is pi radians. 60 degrees, pi over 3 radians. So we need to do pi minus pi over 3. So pi over 1 minus pi over 3, let me get a common denominator there, you know. Times pi over 1 by 3 over 3, right? Make that 3 pi over 3. Minus pi over 3 will get me 2 pi over 3. And there you go. That's your quadrant 2 angle. That has a reference angle of 60 degrees, pi over 3 radians. All right. All right, let's see if I can get in number 2 here. All right, so number 2, same deal. I'm going to put that coefficient together and make that f of x to equal 2 radical 2 times x minus 4 sine of x. You know, to help me with the derivative. So f prime of x here, right? We'll take the derivative here. The derivative of 2 radical 2x is 2 radical 2 minus 4 times the derivative of sine x, which is cosine x. Same deal here. We're looking to find a value for x that will produce a horizontal tangent, meaning the slope is 0, right? So set that equal to 0. Right? We want the value for x. We're given the slope. The slope is 0. At what x or you know, x is gets us that slope of 0. So same deal. It's a linear trig equation. We're going to isolate for cosine of x. And subtract 2 radical 2 here, both sides. Divide both sides by negative 4 here. And negative 2 radical 2 over 4, negative over negative, right? I'll make that a positive. So 2 radical 2 over 4, I can reduce the 2 and 4. That's not butchering, right? To 1 over 2. So radical 2 over 2. Right, so cosine of x is radical 2 over 2. So at what x, right, does the cosine of that angle or angles equal radical 2 over 2? Remember, all students take calculus here. Cosine of x, cosine of x is a positive, right? Radical 2 over 2. Cosine is positive in quadrants 1 and 4, right? So we got to get the quadrant 1 angle, quadrant 4 angle. So once again, that's an exact value, right? Cosine of x to be radical 2 over 2. We go back to our table here. Cosine radical 2 over 2 is here at pi over 4 radians. Okay. So pi over 4 is, that's 45 degrees. Alright, so pi over 4 is the quadrant 1 angle, right? Pi over 4 radians. Cosine is also positive here in quadrant 4. So I want an angle in quadrant 4 whose reference angle is pi over 4 radians, but I'll use the 45 degrees just to help explain this. Right, so what are we doing here to get this angle, right, who has a reference angle of 45 degrees? Well, that's going to get you, right, a full rotation there. Right, so to get this angle, you got 45, and then, you would take 360 minus the 45 to get this guy here, wouldn't you? Right, that angle rotation. Now we want that in radians. Pi radians is 180 degrees, which means 260 degrees. 360 degrees is 2 pi radians. So you're going to do 2 pi radians minus the 45 degrees, which is pi over 4. Right, we will get common denominator here, right, and make that 8 pi over 4 minus pi over 4. And there's your quadrant 4 angle in radians, people. 7 pi over 4. Those are the two values for x where you're going to have a horizontal tangent, people. At pi over 4 radians and 7 pi over 4 radians. And like I said, use the degrees. If the numbers help you out here, you do that like I did.